It's 3 practice problems. Each gives you one network and one mask that's used to subnet the whole network. Your job? Find all the subnet IDs. Let's do it. You'll find matching content in the CCNA Official Cert Guide Volume 1, Part 4, Chapter 15. So let's practice the task again. I give you a classful network and one subnet mask. Your job is to predict all the subnets in the network, but the list could be long. So just find the first several, that is the numerically lowest subnet IDs. That proves that you can figure out how to start the list and find the first few, and find the last few, that is the numerically highest subnet IDs, which shows that you can find the end of the list. What networks and masks? Here you go. There's problems 1, 2, and 3 with the 3 networks and the 3 chosen masks. I'll give you a few seconds to hit pause, go off and answer these questions, and then after that, I'll explain how to find the answers for each. So here's a reminder of the questions. We'll talk about problem 1 first here with network 10. And the goal is for you to list, say, the first 4 subnets, that is the numerically lowest 4 and the numerically highest 4 subnets when using this mask. I'll give you one more chance to hit pause and go answer before I show you what the answers are. So here we go, a few more seconds. All right, here are the answers. So in this case, the numerically lowest are 10,000, 10,800, 16, and 24. So we're incrementing by 8s here. And the last 4, as you see there, ending in 10,248,00, which is indeed the broadcast subnet. So how do you find those answers? Well, if you use the processes I describe in the books or in the videos in this course, you start with a classful analysis. That is, you figure out the number of network, subnet, and host bits, finding 8, 5, and 19 of those. Then any octet that has subnet bits, like the second octet, we consider to be the subnet octet. And that's where you increment to find the next subnet ID, whereas the network and host octets stay the same throughout all the different subnet IDs. So you set up a place to work, in this case with one network octet, the first octet, one subnet octet, and 2 host octets, so with a little more width to write in for those 2 host octets. Then you write down the network ID as your first subnet ID, because that's always the first subnet ID. It's also called the 0 subnet. It just happens to be the same number as the network ID. So there's subnet ID 10,000. And then the network and host octets will be the same thing for all subnet IDs. The question becomes, what are the values in the subnet octet? And it's clear from the answers that these increment by 8 for each successive subnet ID. But the reason for that is we take the mask in dotted decimal format, and we look in this subnet octet and find that its value in the mask is 248. Subtract that from 256 always, and we get an 8. And that's that increment from subnet ID to subnet ID. So that's why we see 0 plus 8, plus 8, plus 8, plus 8, plus 8, all the way through 248. Then the question becomes, how do I know the one that has a 248 in it is the broadcast subnet? Well, if you were to add 8 more, you'd get a 256. That's an illegal value. You could write it down and put a line through it as a reminder, or just not write it down. But the one before it that's not illegal, that's the broadcast subnet. So summing up, there are your first 4 numerically and your last 4 numerically subnet IDs for problem number 1. So here's a reminder of the 3 problems, and we're going to focus on problem 2 next. So for problem 2, here's the space to write. If you haven't answered yet, go ahead and answer now. I'll give you those few seconds to go ahead and hit pause, and then I'll tell you how to find the answers. All right, here we go. In this case, here are the answers. Here are the first 4 numerically lowest 4 subnets, 172.22.0, 32, 64, 96, incrementing by 32 in the third octet, and then ending with 224. As it turns out, those are all the subnets. We're not skipping anything in here because there's only 8 subnets in this case. So that's all of them. So how could you find those? Well, you start with a classful analysis. Since we're subnetting a Class B network, there are 16 network bits. So for our process, the first 2 octets are considered to be network octets. We've got 3 subnet bits. That means the third octet we'll treat as a subnet octet for our process. The fourth octet, it's all host bits, so we'll treat it as a host octet for the process. That means we leave 2 octets over on the left in our place to write the answers. The third octet is the subnet octet, the fourth octet as the host octet. So then how do we start writing the list? We start by rewriting the network ID over here, 172.22.0.0. It's also the 0 subnet. Then we're going to increment here in the subnet octet where we're just going to copy the network and host octets. So I went ahead and copied down the network and host octets. We'll just add in here. And as you saw in the answers, we're going to add by 32. Why? Because in this subnet octet, the mask's value in dotted decimal is 224. We subtract that from 256, always 256, and get 32. That's how you identify the increment or magic number, as I call it in the books. So that's why we add 32 in each case. So 0 plus 32 to get 32, plus 32 to get 64, and so on. And we stop at 224, and that's the broadcast subnet. One way to know that that's the broadcast subnet is that if you added 32 again, you'd get to 256. That's out of range. So you'd back up from that and use the one with the 224 in it as the broadcast subnet. All right, so that's the process. Those are the answers for problem 2. So here's your last problem, number 3, with 192.168.8.0. You're going to list the first few and the last few subnets, and I'll give you a few seconds to hit pause and do it if you haven't already. Last chance, folks. All right, here are indeed the answers. So the first 4, 192.168.8.0, 8.4, 8.8, 8.12, clearly we're counting by 4s there in the fourth octet, ending in .252 for the subnet ID for that last subnet. So how do you find that? All right, so you start with a classical analysis. You find the number of network, subnet, and host bits, 24, 6, and 2 in this case. So all of the first 3 octets have network bits in them, so the first 3 octets are network octets for our process. At least some of the bits in the fourth octet are subnet bits, so we treat that as a subnet octet for our process. And since there aren't any octets that are all host bits, there aren't any host octets for our process. So our workspace looks like this, 3 network octets and just the subnet octet for the process, all right? So what do we do in our process? Well, we write down the network ID again as the first subnet ID. It's also known as the 0 subnet. The very first subnet ID, the lowest subnet ID numerically is the same number as the network ID. And then the network octets are the same value all the way through here. So you could go ahead and copy those down. And then we're going to add something in the subnet octet. There's no host octet to worry about. We would copy that down, but there's not one to worry about in this case. So why do we add, I think it was 4 in this case, right? Well, it's because the mask has a 252 in it in that fourth octet. So you take that 252 and subtract it from 256, always 256, and you get a 4. So when you're calculating the next and the next and the next subnet ID, you add 4. So you take 0, add 4 to get 4, add 4 to get 8, 12, 16, 248, 252, and you stop there, and that's the broadcast subnet. It's the last one, the numerically highest one. And one way to know that is if you were to add 4 again, you would get to a 256. 256 is out of range. You can only use numbers from 0 through 255 in IP version 4 addresses and numbers. So that'd be illegal. You could run a line through it. And the one before it then, by implication, is the broadcast subnet. So just to sum up, there's your answer table with the first 4 and last 4 subnet IDs. I hope you enjoyed this practice. If you want a little more depth on the process that you just saw 3 times, click on the video on the left and you'll get to the instructional video about this topic. But if you're ready to say, hey, I need to dig in and master subnetting and get good at all those processes, click over on the right. It's the part review video that gives you advice about how to study subnetting since we've just finished up an entire part of the course that's all about subnetting. Hey, hope you're enjoying things here. I'll talk to you soon.